welcome to the video again. In this video, we are going to discuss some next topic. Right. So let's in this lecture, we are introducing next new topic, combinatorics. Combinatorics, right? In combinatorics, we will discuss permutation and combinations, then summation, then recurrence relation. Right. These three topics are important, and combination of the three topics makes combinatorics. All right. So let's discuss some fundamental. So next topic is here the fundamental principle of counting. Right. Number one is multiplication rule. Right. Like E for event, then E1, E2, E3 dot and EX. So what is multiplication rule is here? If there is an event, all right, this is an event E, and we can divide it in multiple events, all right, E1, E2, E3, and E4. So, all right, and so on, En, Ex, all right. And what we are saying is, if every event can be done, let's say, even event can done by in one ways, all right. Event E2 can done by in two ways, and event 3 and 3 ways, and n ways, right? Nx we can say. Nx ways we can done event E3, all right. So how many ways? Many ways we will do event E, all right. So the answer would be like is equal to n1 cross n2 cross n3 and dot nx. This is the principal multiplication rule, right? So, for example would be great to understand this. For example, let's say event E is getting ready, for some school. So we can divide this getting ready event is we want to wear pants and shirt. Alright. There are three choices of pant. Alright. Pant 1, pant 2, and pant 3. And then there are two types of shirt. Shirt 1 and shirt 2. Alright. So how many ways I can get ready? Alright. So there are three here, two ways here. So I can get 3 into 2 ways equal to 6 ways. In 6 ways, I can, right? And so, for example, let's say pant P1 and shirt 1, P1 and shirt 2. This is 2 ways. P2, shirt 1, P2, shirt 2, P3, shirt 1, pant 4, pant 3, shirt 2. These 6 ways are there. Alright. So we can count this multiplication rule. So like that. Alright. Next would be the summation rule, addition rule. So let's discuss what is addition rule here. So what is addition rule? Addition. So addition rule is when you have two or more mutually exclusive events. So right, mutually exclusive events is like they can't occur simultaneously. Okay, so mutually exclusive events. Then it state that if event A can occur in m ways and event B can occur in any way, and these events can't occur simultaneously because it is a mutually exclusive events, then the number of ways these events can occur is implicit. Alright. For example, we can take some example here. For example, let's say uh, arrange at least 3% in a row. So how many ways with 5%? 5%. So solution for this would be, so let's say uh, so at least 3%. It could be 3, it could be 4, and it could be 5%. All right. So let's say m is number of ways to arrange 3%. All right. So arrange 3%, it would be like uh, there are three places. For one place we can get five ways we have. For second we have 4 ways, and third we have 3 ways. So we can multiply them, and it would become 60. So if we want to arrange 3% with 5% in a row, then there are 60 ways. All right. Let's say we want to arrange 4% in a row, amen. Then it would be like 1, 2, 3, and 4. It would be 5, 4, 3, and 2. Then it would be 120. All right. But we want to arrange 5%. Let's say mn p. It would be 5 into 4 into 3 into 2 into 1. It will be 120. All right. So either we can arrange 3% or we can arrange 4 or we can arrange 5. So we cannot arrange simultaneously 3 and 4 and 5%. So these events are mutually exclusive, event E1, E2 and E3. So number of ways, so total number of ways is equal to 60 plus 120 plus 120 is equal to 300 ways. All right, this is the answer. So next we are going to discuss permutation. What we understand the addition rule and multiplication rule. So next we will discuss permutation. So number no permutation, or we can say second name is arrangement. Right? Arrangement in which in permutation arrangements order matters. Order matters means A B is not equal to B. Alright. So for this we have a formula NPR. We represent permutation with NPR, which is n factorial upon n minus r factorial. Alright. For example, 10 letters. So find number of ways to 4-letter words with no repetition. Actually, this formula is for no repetition. Alright. So 10 letter, find number of ways to 4-letter word, no repetition. So there are 4 letters. One we want to make 4-letter word. There are 4 letters. What we can put here? There are option for 10 letters. Here is 9, 8, and 7. Alright. So we can multiply this with multiplication rule, and it would be like 10 factorial upon 10 minus 4 factorial. Alright, equivalent to this. This is how we can do this. Here n is 10 and r is 4. Right. Second is combination. Second topic is combination, in which order uh, we can say arrangement in which order of sequence doesn't matter. Right? It can represent by NCR. It is also for no repetition equal to n factorial or r factorial upon n minus r factorial. For example, there are 10 people, right? Select 3 people. So in this order does not matter. We can select any of the 3 people from them. So it would be like uh, 10 CR is equivalent to 10 PR upon R factorial. It is 10 P3 upon 3 factorial. Alright, this is how we do this. So because we are dividing 3 factorial because here people 1, people 2, and people 3 is equal to people 2, people 3, and people 1 equal to people 3, people 2, and people 1. Alright, these all arrangements are equivalent to each other. So 3 is equal to 1. Yeah. In combination, but in permutation, this is combination, but in permutation, order matters, and P1, P2, P3 is not equal, does not hold for P2, P3, and P1. Alright. Next, we will discuss 9 categories of problems in permutation combination. There are wait a minute, someone is calling me. हेलो हाँ जी कौन सा कौन सी कंपनी है हाँ जी मुझसे मिस हो गया था मैम मुझे पता ही नहीं था कि उसका